Dear students, welcome to the new lecture of characterization of materials. Today topic of discussion is scanning electron microscopy. Um, this piece of equipment is abbreviated as SEM, and actually it's more famous um, or known by its abbreviation, which is the SEM, than its full name. So whenever you have to recall this equipment, you can easily say SEM, so you don't have to recall the full name, the scanning electron microscopy. So this was an interesting part of this equipment. um, so if you have any questions related to this topic, um, by end of lecture you can ask either by Google Classroom or WhatsApp group. And before proceeding to the normal topic, just let's um, keep the things in the perspective that the things that visible to us and invisible to us. Um, in this slide, you can see the number of objects and their size in the meters. So the range is from 10 to the raised power 3 meter to 10 to the raised power minus 10 meter. So 10 to the raised power 3 is nearly 1 kilometer or 1000 meter. So the football fields or the field similar to like football, cricket or something else, they all came under the this range, which are visible to us. Our house, which is nearly like it varies from um, 10 meter to 30 meter or in similar range. They are very much visible to us. The baseball and the other balls of like tennis, cricket, which are visible to us, they are like of the size nearly about um, 10 to 20 centimeter or in a similar range. The cherry and the fruits in a similar size like the blueberries, which are visible to us, we can easily see these. So they are 10 to the raised power minus 2 meter or 1 centimeter. Uh, the interesting point comes here about 10 to the raised power minus 3 is the just dot or period. So it's nearly 1 millimeter in size. Whatever you write on the Word or Excel or in the even in the PowerPoint, if you end with the period or punctuation dot, uh, it's visible to us, clear to us, and the size is nearly 1 millimeter. If you further go to the down size, like if you want to see the cell or bacteria and virus and protein and the molecule of water, so the size is too much less that it's nearly invisible with the naked eye. So to see these structures, we need instruments or equipments such as light microscope. The light microscope that you use in your um, uh, 9th or 10th grade or 11th to 12th grade, or maybe in your bachelor classes, um, uh, you can see the size of cell and even bacteria, which is in range of 10 to the raised power minus 4 to 10 to the raised power minus 6 meter. Um, when we go to the less than 10 to the raised power minus 6, like if you want to see the size and shape, structure of virus, protein or water molecule or else, you need some specialized equipment just like SEM, scanning electron microscopy. Um, so all this structure will be visible with these sophisticated equipments. Um, so the visible range is like 10 to the raised power 3 on little bore to 10 to the raised power minus 3, which is nearly 1 millimeter. We can see the things in this range. Below this, nearly impossible to visualize it with the naked eye. We need specialized equipments just like light microscope or scanning electron microscope, the topic that of our today discussion. So hopefully understand this. To clear it more, in the next slide, uh, we will discuss the things in more detail. Let's keep the thing in perspective. Um, in this slide, again, I will discuss the visible and invisible range. Um, so we are comparing the structure which is known to us and in the visible range to the structures or bodies or objects which are invisible. So if you can see a circle on the top left hand side of this slide which represents a diameter of a normal human hair. So the diameter of this circle is about 100 micrometer. I'm not saying the actual size of the circle, just I'm telling you about the diameter of hair, which is the hair of a normal human being is about 100 micrometer, and just I'm drawing the diameter of a normal human being hair as a circle, which is on a much bigger scale on this slide. So let's assume if this circle represents the diameter of a normal human being hair, so the bacteria which is the size of 10 micrometer will be a ball, a shaded red ball, and definitely the size of red shaded ball is much smaller to the size of normal human being hair. So the hair is visible to us and the size of hair is nearly 100 micrometer, whereas bacteria size is about 10 micrometer and it is an invisible range to naked human being. So naked human being eye, sorry. Uh, Similarly, the road dust particles, they are nearly impossible us to see them, so they are in the range of 5 micrometers. Similarly, the coal dust particles, they are about nearly about 2 micrometer. They are floating in the air because of their lightweight. Similarly, if you can see the virus, the size of virus, which is about 0.4 micrometer, and in this slide it's just represented by a dot as compared to the circle which is representing the human hair. So the size of virus is so much small, as tiny as dot, if you compare to the size of hair, which is a big circle. Similarly, the vehicle emission is about the size of 0.2 micrometer. So it's again is a smaller dot than the virus, but we cannot see them. The scale drawn on the right hand side, on the top right hand side, is just to mention the relationship between the sizes that I have shown you on the left hand side. So what is a centimeter, what is a millimeter? So just to visualize the things in the easy way, um, I took the scale that we also call ruler, which we are using in daily routine. So as I mentioned, the hair, a big circle. If we can see this big hair, not a big hair, it's just a hair, normal human being hair, by scanning electron microscopy, and then the things that are visible to us by naked eye is totally different if we visualize the object under scanning electron microscopy. Normally, if you feel the hair of your head, that if you feel it, then the surface look like very smooth and slippery, but in reality the skin is the outer skin of hair is not smooth as we feel. Actually, it's the outer skin of hair is just like a scales. um, if you see the fish skin, it has scale on it, so the outer skin of hair is very much similar to the skin of fish, so it has scale on it for the protection purpose. And then inside the hair there is a complex structure. So there are some other stuff made of cells. So the hair, which is look very simple and naive by the naked eye, is not simple um, in principle, but it's made of number of stuff or number of cells. um, so the things are becoming very interesting if we see these objects under like sophisticated equipment. As an example, scanning electron microscopy. So the bottom left image is taken by the electron microscopy, scanning electron microscopy by the magnification of 1200 as compared to the normal. Whereas the size, as you can see, the line, a bar, this represents a 10 micrometer. So if you multiply this 10 micrometer by 10, then you will get the diameter of this hair, which is nearly 100 micrometer, as shown on top right hand side of this slide as a big circle. So the things that look very simple and naive by the naked eye are not simple. They are complicated structures, um, and this complicated structure behave differently if we view them by the scanning electron microscopy.